Hello, pre-algebra students. We're moving through chapter 8. We're ready for section 7. In this section, we're going to be graphing equations using slope-intercept form. To the right of your paper here is a little preview of slope-intercept form, what that's going to look like. Before we get into the new material, I would like for you to stop the video and be sure you attempt these 3 review problems provided here. I do want you to pause the video. I'm going to work out each problem and I want you to check your work with my work. So if you don't pause the video, you will not see the problems worked out. You're only going to see their solutions. All right, feel free to pause the screen if you need to stop and study my work. But I've written out the slope formula, how I always remember y over x, and there's the formal formula. I plugged in my numbers and I solved. When I'm looking for a function, every x needs to have one and only one y. And my direct variation equation is y equals kx. And they gave me y and they gave me x. And it said to find the constant. So k is the constant. I found k by dividing both sides by 3. All right, so we are ready for our new material. Slope-intercept form of a linear equation. You're always going to have an x and a y. Well, I shouldn't say always. There are a rare occasion where you don't have an x or you don't have a y, but you always have one or the other. So the most linear equations have a y and an x. So y equals mx plus b is slope-intercept form of a linear equation. Now, M here should be kind of italics like it is in A. M stands for slope. So whenever you have a number in front of your x, and your x is not being squared, and your y is not being squared, it's a linear equation. The number in front of x is your slope. B, which is a strange thing, I don't know why they call it B. They can't call it y because you already have a y. So B, whoever maybe named this, maybe his name was Baxter, so he picked B. I don't know. But you need to learn that whenever you see a number without an x, and it's also not your y, that's called a constant. It's a number without a variable. That number is where your graph is going to intercept the y-axis. Intercept, catch. Where it's going to catch the y-axis, that's always B. So everything I've just said for you is summed up in this nice little chart here. And it highlights that M, and M stands for slope. So in this first example that they've given us, y equals 2x plus 6. Our slope is 2. Our y-intercept is 6. So come over to the graph. And this number is 0b. Well, for this problem, it's 0, 6. Because it catches the y-axis at 6. This graph is a falling slope, so we know this is not the graph of this line because this is a positive slope. So from 6, you would rise up 2 and run 1. So you'd rise 2 and run 1. We did a lot of graphing a couple of days ago of direct variation equations where the y-intercept was at 0. So you know the process of rising and running from 0. Now we're going to rise and run not from 0, but from our y-intercept. So let's work a few more problems. On the next page, you'll find some equations already solved for y. So I immediately know that my slope here is 2. M is 2, and that almost looks like a 3. M is 2, and my y-intercept, B, where it catches the y-axis, is 3. So to graph this line, the first thing I'm going to do, this is your first move, move number 1, is to go to your y-intercept. And we're going to go up to 3. There it is. I know my line, whichever way it goes, it's going to hit the y-axis at 3. From 3, my slope is 2 understood over 1. So from 3, this is step number 2. we're going to rise 2 and run 1. Now, I've told you before you only need 2 points to graph a line, but it'll make for a neater line if we go ahead and rise and run. And by the way, if I rise -2 and run -1, -2 over -1 is the same thing as 2 over 1. So that makes it for a very neat line. And there it is, the graph of number 1. All right, you want to try number 2? Why don't you pause here and try number 2 on your own. Pause it. All right, I hope you've tried it. Let's check your work. Slope is rise 1, run 2. Y-intercept is -1. Remember, the number, or excuse me, the sign in front of the number stays with the number. So that's really plus a -1. So realize that your y-intercept is at -1. So step number 1 is to start with your y-intercept, -1. From -1, step number 2 is to rise and run. So from -1, I'm going to rise 1 and run 2. Rise 1, run 2. I can go -1, -2, -1, -2. Makes for a nice, neat graph, especially since you don't have a straight edge in your hand. Just in case you didn't follow how I was able to get these left 2 points, our slope is 1/2. But guess what? -1, wish my pen would work, over -2 is the same thing as positive 1/2, because negative over negative is positive. So when I've exhausted all of my options going up, to be able to go down, you just have to change the signs, negative over negative. I did the same thing here. From rising 2, running 1, I ran out of space, so I said, well, then I could also look at that as -2 over -1, because -2 over -1 is the same thing as 2 over 1. So don't forget what you know about manipulating your signs. All right, let's look at our next example. Write and graph an equation. So they're not going to provide the equation for us. It says, write an equation in slope-intercept form of the line with a slope of 1/4. Wait, stop right there. M is what? 1/4. That sounds like important information to me. And a y-intercept of -1. Oh, a y-intercept, that's my B. Y-intercept is -1. So they gave us a hint here. This is the equation we're looking for, the form of the equation. So write the equation and then graph it. So here I go. Y equals M, which is 1/4 X plus B. And you're welcome to say plus a -1, but most people know that a positive and a negative really makes a negative, so you're going to see this more often than plus a negative. So it's okay to think through that process. I need to also graph it. So step number 1 is to start at my y-intercept, which was -1. Step number 2 is to rise and run. And I don't know why. I think it doesn't like the graph. Hang on. Okay, so on the graph, I need my green. From here, my y-intercept was -1. From here, I'm going to rise 1 and run 1, 2, 3, 4. Guess what? I'd like a third point. So from my y-intercept, if I rise 1 and run 4, I run off of the graph. So don't forget, M is 1/4. That's the same thing as -1 over -4. And I'm having technical difficulty. -1 over -4. It's the same thing, and my pen doesn't want to catch. There we go. So from here, I'm going to go -1, -1, 2, 3, 4. All right. Pause the video and try the next one without me. See if you could do that on your own. Write an equation in slope-intercept form of the line whose slope is 4 and whose y-intercept is 3. So this is our form that we're looking to write it in. They told me slope was 4, y-intercept is 3. So here I go. Y equals 4x plus 3. Come over to your graph. Step number 1, find your y-intercept. 1, 2, 3. There it is, positive 3. 0, 3 is the first point. From there, be careful, our slope is 4, which is understood to be over 1. So I'll rise 1, 2, 3, 4, and I run 1, means it's a very steep line. I'm out of space, so let's remember to go -4 and -1 just to be thorough. -1, 2, 3, 4, -1. 3 points will make for a neater line than 2 points any day. And so that is the graph. Example 3. Graph these linear equations, and the first equation is not in the form y equals mx plus b, but that's my goal. So I am going to need to solve for y. So the first thing I'm going to do to isolate y, I have to do the reverse order of operations. So let's take care of moving our 5x to the other side. I'm going to go through the mathematical process of saying minus 5x, but in my head I'm thinking hop the fence, change the sign. I need 5x to go over our little fence, which is our equal sign. So when it hops the fence, it changes its sign to -5x plus 8. The reason I'd rather hop the fence than to actually do the math is because these aren't like terms, and I don't want to accidentally say 8 minus 5 because 8 does not have an x and -5 does have an x. So be careful. So to now get y all alone, undo the multiplication of y, which means to divide everything by 4. I can't just divide one number by 4, or the rest of my students will say, hey, what about me? So I have to divide the whole equation by 4. So our final equation for number 1, and I'm kind of moving horizontally here, y equals, because that becomes a 1, -5 over 4, that's my slope, x, plus, hey, 4 goes into 8 evenly, it goes 2. So what was my slope? -5/4. What's my b? 2. So if I come over and I graph, let's do it in blue since most of my work was done in blue. Come up to 2, I'm going to go -1, 2, 3, 4, 5, 1, 2, 3, 4. I did that quickly, let me make sure. Okay, for the sake of time, I'm not going to find 3 points, I just found the 2 points. So there's our first problem worked out. Let's do the second one in red. So I need to isolate y. Let's take 3x to the other side, hop the fence, and change the sign. Makes it -3x plus 6. Divide everything by 2 to get y by itself. So y equals, because that becomes 1, y equals -3/2 x plus, and 2 goes into 6 3 times. So our slope is -3/2, and our y-intercept is 3. So let's use red since that's the primary color I was using. Since we're sharing a graph, we'll do number 2 in red. So I go to 3, 1, 2, 3, and I'm going to rise -1, 2, 3, and run +1, 2. So they are very close to each other, but they're not the same slope. And I do have a straight edge I'm trying to use. Oh, it worked nicely for the red one. I'm going to need to make my blue one neater. Hang on. Maybe that's a little bit better. All right, so our last equation does not have an x. It's 5y equals 10. So remember, our goal is to have slope-intercept form. So I need to isolate my y. The problem is, without there being an x, that means that m must have been 0. So when I divide both sides by 5, I will end up with y equals 0x, because there are 0 x's, plus, and 5 goes into 10 2 times. So my slope is 0, my y-intercept is 2, and think about it, I gave you a mnemonic. When our slope is 0, what kind of a line is it going to be? It's going to be a horizontal line. So let's go back up to our graph. We intercept the y-axis at 2, and it has 0. Check your understanding doing these 4.